Welcome to Easy Maths. In this particular lesson, we're going to focus attention on rationalizing the denominator and the use of what we call the conjugate. And maybe we need to turn there right away. Now, rationalizing the denominator normally involves making the denominator a rational number. Remember, we're talking about a case where the denominator is not rational, it's a surd. This involves removing the surd from the denominator of that particular fraction. Now, if you consider the example that you have on your screen there, 1 over root 5, to rationalize this would mean we remove the surd from below the division line, and this is what we do. Normally, the operation when we have a single term for the denominator involves multiplying the denominator with itself, so that the square of the root removes the root, just giving us a 5 in this particular case. And whatever thing we multiply the denominator with, we also multiply the numerator with the same. And so we multiply with square root of 5 divided by itself, so that the denominator will cease from being a surd. And so the answer will simply be root 5 all over 5. And that is the technique used in the cases where we have a single term for the denominator. If it was, say, 3 over root 11, it means we would multiply 3 over root 11 by root 11 over itself. And this is what we have. And therefore, the numerator will be 3 root 11 all over root 11. Again, if we're having 5 all over 2 root 3, we'd have to multiply both the numerator and the denominator with 2 root 3, which would be this sort of a thing, and the answer would be simply 10 root 3 all over 12. Please notice that in all of these cases, 1 over root 5 is mathematically identical to root 5 over 5. 3 over root 11 is mathematically identical to 3 root 11 over 11. And 5 all over 2 root 3 is mathematically identical to 10 root 3 all over 12. Turning on to the use of a conjugate, I need to say the following. Consider the expression 3 root minus root 2 times 3 plus root 2. Now, the 3 minus root 2, that is the first bracket, and 3 plus root 2, the other bracket, are normally conjugates of one another. And if they are multiplied together, they would reduce to a difference of 2 squares. And we have done this sort of a question in a previous lesson. Now, this bracket times itself, being a difference of 2 squares, would just have 3 squared minus root 2 squared, which would be 9 minus 2, which will be simply 7. This technique is used to rationalize denominators when we have 2 terms in the denominator. For example, if we have 1 all over 3 minus root 2, we would have to multiply that expression with the conjugate of 3 minus root 2 as a numerator and a denominator. That means since the denominator should be multiplied with its conjugate, 3 plus root 2, we also have it for the numerator, so that we don't change the expression, and therefore it will simply be this way. I believe an examiner would not be worried about how you got the 9 minus 2, so you don't need to struggle with showing how that is arrived at, since at this point students are being tested in just the concept of surd, not difference of 2 squares. So I think it's fair to write just 9 minus 2 for the denominator, and the numerator will be simply this way. Now, if you simplify this, we'll have 9 minus 2, which is 7, and that's simply the answer there. So that's the technique there. We use a conjugate of the denominator to rationalize the denominator when the denominator has 2 terms, like 3 minus root 2, or even 2 surds, or whatever the surd is appearing. If a given 2 root 3 all over root 5 minus 7, would again multiply with the conjugate for a numerator and denominator, the conjugate of root 5 minus 7, therefore would have this sort of a thing, and it would be this sort of expression here. Remember, 2 root 3 times root 5 would be 2 root 15, and 2 root 3 times 7 would be 14 root 3. The denominator would be simply 5 minus 49, and it is simply this sort of an answer here. 5 minus 49 is negative 44. I think it's possible for us to simplify further, and so this 2 and this 14 and this 44, if you factorized out 2, you would have 2 in brackets root 15 plus 7 root 3. So that 2 can divide 44 to get 22. Again, since there was a negative here, the two upper terms become both of them negative, and so in a simplest form the answer should be like what we have on the screen there. Turning on to another question, we have root 2 plus root 3 all over root 7 minus root 5. Again, to rationalize this, we have to multiply with the conjugate of the denominator, which will be root 7 plus root 5, and there it is, root 7 plus root 5 for the numerator and denominator, and expanding the numerator will be a long time like this, which we have met expressions of this nature previously. And so 7 minus 5 would be 2, and that's simply the answer. What do you have on the screen there in red? The last question, we have root 5 divided by 3 root 15 minus 2 root 10. This would again require us to multiply with the conjugate of the denominator, which is 3 root 15 plus 2 root 10. The numerator and denominator are the same thing, so that you don't change the expression, and therefore it will be this way. And just take care of the big numbers that are appearing there. This would just be 9 times 15, and this would be, I think, minus 4 times 10, because since the square root of 100 is 10, square root of 205 is 15, and therefore the answer should be this way. This should be this one here. What I've done there is I've rationalized 75 to get 5 root 3, and 5 is multiplied by 3 to get 15, so we have 15 root 3, and 2 root 50. The 50 can be simplified by having 25 times 2, square root of both of that would get 5 times 2, which is 10, and so we'd have this sort of a thing here, and then we simplify as required there. Now the answer would be like this once we have simplified, and having gotten that, please notice that I factorized out 5, since 15 and 10 both have 5, so we have 5, and 5 getting out would have a 3 and a 2 for this term, and this other one here. I'm saying 5 times 3 would be 15, and the 5 times 10 would be this 10 here, and root 3 root 2 appear there. Anyway, I know you can be able to simplify that at this point. Therefore divide both sides by 5, you get the answer is 3 root 3 plus 2 root 2 all over 19, and that is the answer. Please check out for more videos coming on the same area, but this time round we're going to have mixed concept on Surds. Please like, share, subscribe. I'll appreciate it. Thank you.